with Team Uber, and we were tasked with the rather broad question of how do we do something new and interesting for Uber that they haven't already done. And so we start off with a few directions. There was the advanced Uber reservation, the exclusive Uber content, car-to-car networking, and sort of like a socialization for carpooling. But none of this we felt really answered the big question of what is the future of Uber? Well, from our research, we find that there's around 100,000 Uber rides per day in New York City. Compare that with around 5 million subway rides, and we realize this essentially a huge potential market for Uber. And we asked ourselves, what if we link these two entities together? So we found that we were not the only ones thinking this way. There were a few parties and stakeholders each believing that the future of Uber really is to make it sort of an option in public transit. And while we were working on this, just a few weeks ago, Uber's biggest competitor, Lyft, has already started doing this. But we realized that with Uber's existing assets and business model, we can push this further with our application. And Yang's gonna tell you sort of our demo.
Yeah. So let's go to the demo. So now I'm in our app. I just want to go from Cornell Tech to Cornell Wild. So I just put in my location and destination and I click route. I get a list of options. You can see there's a public transportation options and also Uber all the way. But I can get an option with Uber and also public transportation. When I click inside, I can see all the details. So that's basically what our app did. Okay, let's dig in deep into the architecture. All of the things you see is happening real because of the Uber Transit API we are building. The API actually talks to the Uber server to get the map data and also the MTA data. And it talks to the Uber server to get the price and time for Uber. And after that, it integrates all these results, optimize it, and feed it back to the interface.
So what sort of learnings did we have that enabled us to come up with this ultimate app? The first thing is we talked to transportation policy experts at Harvard, Cornell, and New York City MTA. And we were able to find that people are willing to walk up to a half a mile for transportation. So that's what you saw there. Our app is basically finding walks of more than 10 minutes and stubbing them back in with an Uber based on the price and distance that the Uber API provides. So you saw one example of a trip from Cornell Tech up to Weil on the Upper East Side. There actually may be another application of this, which is in suburban areas. Take the map behind me shows northern New Jersey Uber trips just in October of this year. And 1 in 4 Uber trips started or ended at a rail station. And you can see over time, this is happening organically. This is 2013 to 2015. We're seeing this happen even without our app. So a quick look at what this market looks like. We have 300,000 Uber rides that started or ended at a rail station. Of the 6.6 million Uber public transportation rides that happened in northern New Jersey in October. So we end up with a 3.6% of the market. Using our Uber pool data and pricing, we're able to calculate across the United States that'd be a $2.6 billion a year market. So it's really a big market that Uber could be attacking here.
So as we started moving further, we were wondering how could we make this product more successful. So we realized that introducing our API in key geographical areas that is probably 0.5 or more miles nearer to this transit hub would make it more successful. And the major KPI is the usage of the application 7 days a week.
And for next steps, first of all, we've transferred and done our final presentation to Uber. We'd like to thank everyone here at Cornell Tech and Uber for a fantastic semester.
What was the time? 4:18.